Dear students, in the previous set of videos, you had learned about certain basic combinatorial circuits such as the AND, OR, NOT, and other fundamental logic gates, as well as multiplexers and decoders. So, in today's video, we shall look at the process of making a generic arbitrary combinatorial function using some of the functionalities of the CircuitVerse. So let's see how to make it. We see the circuits option over here. You click on this and we go to the tools option. So in the tools option you can see this combinational analysis, so I shall be explaining very soon. So you click on this. Alright, so let's suppose the combinatorial circuit that you want to make has 4 inputs A, B, C and D, and each of these inputs can take 2 values, that is 0 or 1. So basically, since you have 4 inputs, so corresponding to these 4 inputs A, B, C, D, you have 2 to the power 4, that is 16 possible values. Now let's suppose from these 4 inputs you want to get some combinatorial function, which, let's say I want to write that function as x, and if you want to create another function with a different feature or functionality, let's put y. Alright, now click on next. Okay, so what you can see in this table is the list of possible values that can be taken by this input bits A, B, C, D. So starting from all the way zeros to all the way ones. Okay, so that's all zeros meaning 0 and all ones, since it's 4-bit, it's 15. Now over here you can see the output functions that we want to define. The function 1 is x and the function 2 is y. So what we can do over here is we can, corresponding to each set of inputs, we can define whether we want the output to be a 0 or a 1. Okay, so let's suppose then that's your choice, or it depends upon the function or the functionality of the circuit that you want to implement. So later in this course, when you will be solving tutorials, you will be given some real life problems where based on some combinations, let's say you have 3 switches corresponding to in a room, corresponding to whether a light should be on or off, or whether a buzzer should be buzzer in a aeroplane should be on or off, and on or off will depend upon certain factors. Let's say there's a sensor that measures the temperature in the air cabin, another sensor that measures the pressure in the cabin, and some other sensors which measures, let's say, the amount of fuel left in the chamber. So based on certain combinations, let's say you have the sensor being 1 when certain conditions of the fuel is being satisfied or not. So depending on those set of conditions and properties, you have to set the function output value. So let's suppose I give some random values. I choose 1 over here. You can click on this and change the value between 0, 1 and x. What does this x means? The x actually refers to the don't care condition. That means that you will, when you create this circuit, you are not concerned about what this output shall be when you give this set of inputs. Okay, and when you do this, the circuit that is made is actually done, the circuit that is constructed is done in such a way that the number of gates or the computation that is required is reduced. So the more your circuit has such access, the easier or the simpler your circuit will be, because our main objective is not just to create a circuit, but to create an efficient circuit which can fulfill all our purposes despite using the least number of resources. Okay, so as you can see, I'm just giving in some random numbers. So I select some ones over here. Alright, now I do the same thing for the second function y. Let me keep two of these don't cares over here. Alright, so first let me print the truth table. It will be saved as a PDF. Okay, so you can see over here we have saved the truth tables of x and y, and now let's click on generate circuit. Alright, so as you can see over here, let me zoom it a bit. A, B, C and D, these are our four primary inputs that we are giving into the circuit, and the corresponding outputs are bits x and bit y. Okay, so let us just verify the truth table that is being shown over here, and this is a constant c, this bar underscore c underscore 1, you cannot change it and it's fixed to 1, so it means this is a VDD or a high, and this one is the opposite one, this is the ground. So this is often done to simplify the circuits that are being made. So now let's see when A, B, C, D, all of them are 0, x should be 1 and y should be 0. So what do you observe? A, B, C, D, all of them are zeros, and x is actually 1 and y 0. So you see it's getting verified. Similarly, you can repeat the entire process for the circuit. Let's put all ones. So for all ones, you can see the output for x is 0 and the output for y is 1. So 1, 1, 1, 1. You can see over here the output for x is 0 and the output for y is 1. Now let's look at the interesting don't care conditions. So you can see number 11, that is A, B, C, D is 1, 0, 1, 1. So for that x is 1 and y is don't care. So let us see what we get. See, A is 1, 0, 1, 1. So you see x is 1 as expected and y we are getting 0. So based on this don't care condition, we actually get a simpler circuit, and based on that circuit the output at y is actually 0. So try to understand that this don't care is not exactly cannot be the output of a circuit. The output will either be 0 or 1, but you are saying this don't care. What this don't care says that even if it's 0, I don't have any problem, or even if it is 1, I don't have any problem, but choose that particular value which will simplify the number of gates or simplify the circuit that is being made. Alright, so let's look at the other don't care case. Okay, so it's 1 1 1 1 0 0. So let us set A, B, C, D as 1 1 0 0. Okay, so 1 1 0 0 has x as 0 and y as don't care. So you see x is 0 and y is 1, which is as per the circuit that has been made. So you can see such a big circuit. I mean, if you look at the combinatorial truth table, so it's a 16 input table, 16 entries are there. So manually, if you try to make such a circuit, you will learn something called the Carnot map. Carnot maps are actually certain mathematical Boolean tools which will help you create efficient circuits for different number of binary inputs. Now if you were to do it manually and then create the circuit on your own, you will get you'll actually, after solving the combinatorial table, the truth table, and using the Carnot map, you will get x and y in terms of A, B, C, D. You will get them in terms of a combinatorial function. But then if you try to make them on your own, putting in all the gates from here and connecting them, you will lose a lot of time, as well as some short circuits and problems may take place. That's why I've shown you this tools option and combinational analysis. using this functionality, you can generate your own function truth table functionality circuit as per your convenience.